So in this video, we're going to talk about how to appropriately name ionic compounds, okay? And the way I like to break it down is just 3 easy rules, and you should be able to get every single time, you should be able to name your ionic compound correctly, okay? So we'll just do the rules first, and then we'll just do a bunch of examples, all right? So rule number 1 is that your cation name comes first. So your cation, your positively charged ion, comes first, and you do not change the name, okay? Okay, there's no change in your cation name, and your cations are metals, right? So you're not changing the metal's name at all. You just list the metal name, okay? Rule number 2, okay, you add Roman numerals to tell the charge of your cation. Okay, your cation are metals, right? Your cations are metals. Most metals fall within this transition and intertransition section. You need to tell what charge they have. So you're going to list the name of the metal, like iron, magnesium, tin, whatever the name of the metal is, right? That's the cation name. Then in parentheses, you're going to put Roman numerals to tell me the charge, okay? And there's exceptions to this rule. So the exceptions are going to be the metals that always have the same charge. So the metals that always have the same charge are going to be alkali metals, which are always +1, alkaline metals, which are always +2, and then you have, right, so all these guys in column 1 are always +1, so I don't need to tell Roman numerals, they're always going to be +1. All these guys in column 2 are always going to be +2. I don't need to say is calcium Roman numeral 2 because calcium is always going to be a +2. So I don't need to say it. Okay, no Roman numerals for these guys and no Roman numerals for your backward stair step. Okay, because aluminum's always +3, zinc is always +2, silver is always +1. Okay, you could also say for cadmium 2+. All right, so our other exceptions are going to be these 3 guys right here. All right, so aluminum, +3, zinc is +2, and silver's +1. I ran out of room, so I'm using their symbols, all right? So those are the only exceptions to the rule. Now I'm done with my cation, okay? I have named my cation part of my ionic compound. So what comes next is my anion. So we have the anion. Name is last. But instead of, like your cation has no change in the name, your anion does change its name. Okay, you change its last name to "ide." You change the suffix, the ending. All right, so this is the ending. All right, so imagine your cation and anion got married, and your anion, after it gets married, is changing its last name to "ide." Okay, and you know this intuitively. If you have sodium and chlorine coming together, you don't say it's sodium chlorine, you say it's sodium chloride, right? You do this already. You just didn't know why, but now you do, okay? So your anion name comes last, and you're going to change the last name to "ide." There is an exception. The exception is that your polyatomic ions do not change their ending. This little triangle is a delta, it means change, okay? So polyatomics never change their ending, they just keep their same name. Let me grab the page here, right? So that's all of these guys, right? Your common anions, so your polyatomics like nitrate, nitrite, perchlorate, chlorate, whatever, okay? All of these names that are polyatomic, so multiple atoms within the same ion, I keep those names the same. I would never change acetate to acetide, okay? It's just that thing is called acetate, boom, I'm done. I don't need to worry about changing the name, okay? 3 simple rules. Cation name is first, add a Roman numeral, add your ion with "ide," okay? Let's practice. All right, so while we practice, I'm gonna have this little section here of our 3 rules just to kind of remind us as we're going through, okay? So again, cation comes first, then Roman numerals, then anion, all right? So here we go. I have this name, right? NaCl. So rule number 1 is that the cation name comes first. So Na, this is sodium. There's no change in the name sodium, so I literally just write out sodium. Okay, boom, sodium. Then I need Roman numerals to tell what charge my sodium is, except if this is an alkali, an alkaline, or silver, zinc, or aluminum. Sodium is in my first column, so I do not need Roman numerals here. Okay, so no Roman numerals, and now I name my anion. This is chlorine, but I'm going to change it to ide. So sodium chlor, instead of chlorine, I'm changing it to chloride. Boom. Okay, easy. This guy, Mg, I name my cation. That's my first rule. Magnesium. Then I'm going to have to add Roman numerals, unless it's an alkali, alkaline, or silver, zinc, or aluminum. And what do you know? Magnesium, right here in column 2. Okay, it's an alkaline metal. All right. So no Roman numeral for this guy because I know magnesium has a +2 charge. Then I have Br is bromine. Doesn't matter that there's 2 of them. I don't care if there's 2. I don't care if there's 52. I'm just getting the name now. Okay, so this is going to be magnesium and Br is bromine. But instead of bromine, I'm going to change it to bromide because I changed my last name to ide. And that's it, magnesium bromide. Okay, next, Fe is iron, right? I name my cation, I name my metal. Then I need a Roman numeral unless it's alkali, alkaline, or silver, zinc, or aluminum. It's like, how many times can I say that, right? But it's okay because you'll remember it. Well, what do you know? Here's iron. It's not an alkali, it's not an alkaline, and it's not one of these 3 with the backward stair step. It's out here in the transition metals. So we actually have to have Roman numerals now. Okay, Roman numeral, and then Cl, we'll figure out how to actually solve for what this Roman numeral is. Okay, Cl is chlorine, and chlorine is going to change to chloride. Now here's the problem. How do I figure out what charge goes in there? How do I figure out what number goes in there for Roman numeral? Okay, remember that Roman numeral here tells me the charge. Oh, that's got cut off. All right, scroll up. Okay, this tells me the charge of that iron. It does not tell me how many irons it is. So please don't put iron 1 chloride just because there's 1 iron here. That's not what Roman numeral tells us. Roman numeral tells us the charge. So now I need to break it down. Okay, so here we go. I have iron, Fe, and I have 2 chlorines, Cl and Cl. This is how I like to break it down, okay? Now, I need to work backwards to figure out the charge of my iron, okay? I know for sure that each of these chlorines is going to have a 1- charge, right? I know that for sure because chlorine is a halogen. Halogens will have a 1- charge. So I know that these chlorines have a 1- charge, which means I know that in total, there's a 2- charge from all of my anions, which means if I am making a balanced ionic compound, my anions and my cations have to even each other out. They have to balance. So this side has to have a 2+ charge. My cations have to give me 2+, which means this iron has to have a 2+ charge to balance everything out, okay? 2+ for my iron, 2- from my 2 chlorines, which means this iron is an iron 2. So iron 1,2 chloride because it has a 2+ charge. Let's do another one. All right, so 3 more. Okay, here we go. I name my cation first. So Cu is copper. Then I'm going to have Roman numerals. Okay, because copper is in fact a transition metal. Okay, it's not one of the ones that I know what their charge is for sure. So I'm going to have to specify what charge that copper is. Then I have, and we'll figure out what that Roman numeral is afterwards. Okay, we'll figure this out in a second. Then I have NO3, okay, as my anion. If you're looking on your periodic table, you're like, dear God, what's NO3? Nitrogen oxygenide? Ooh, what do I do? No. Okay, this is when your common anion sheet comes into play. You have to know your anions, okay? You have to know your common anions. So I scroll down my page and I'm looking for NO3, NO3. Oh, let's actually make it so you can see. NO3 is nitrate, okay? So I'm just gonna straight name my polyatomic, right? There's no changes in the ending when it comes to my polyatomic. So it's gonna be copper something nitrate, because NO3 is nitrate, okay? Now I need to figure out what the heck Roman numeral I have. So we break it down. So I have 1 copper and I have 1 nitrate. Okay, I need to figure out what charges these guys have. So this nitrate, NO3, again, use your reference sheet, okay, if you don't have it memorized. NO3 has a 1 minus charge, if you can see that. Okay, so NO3 has a 1 minus. And for this compound to be electrically balanced, my anion charge has to balance out, has to even out with my cation charge. So this copper has to have a 1 plus charge, which means this is copper 1. It has a 1 plus. So copper, Roman numeral 1, nitrate, because that copper has a 1 plus charge. Not because there's only one of them, okay, but because it has a 1 plus charge. On we go. Ag is silver. And then I have Roman numerals, unless I'm talking about silver, right? Alkali, alkaline, silver, zinc, or aluminum. So no Roman numerals, right? Because I know that silver will always have a +1 charge. And it doesn't matter that there's 2 silvers here. I don't care. What I'm trying to do is get the name, okay? So I'm gonna have silver, and then I have my S, which is sulfur. But I'm gonna change sulfur to sulfide. So we have silver sulfide, okay? Sn is tin. Then I'm gonna need a Roman numeral. 10 is here, okay? Roman numeral is needed. Roman numeral, and then I have CO3, and I have 2 of them, okay? So it's gonna be a polyatomic. All I need to do is find what the name is. So I just take my page, and I'm looking for CO3, CO3, aha. Right here, CO3. CO3 is carbonate. And you'll notice it has a 2 minus charge, okay? We'll use that in a second. This will be 10 something. I don't know what my Roman numeral is yet. Carbonate. All right, and now I need to figure out Roman numeral. So I have 110, and I have 2 carbonates, CO3, CO3. And if you remember, those CO3s had a 2 minus charge. Okay, so since there's 2 carbonates, that means there is a 2, oh my, math. That means there's a 4 minus charge total from my anions, which means my cations have to have a 4 plus charge total. And there's only this 110, so that 10 has to have all 4 pluses of that charge to balance out. So this is going to be 10, 4 carbonate. And in case you're not super savvy with your Roman numerals, the I before the V is 4, right? 1, 2, 3 is 3, 1, 2 is 2, 1 is 1. 1, 2, 3, 4, V is 5. Okay, just don't miss a question because you didn't know how to write out 4 in Roman numeral. All right, we'll just do a couple other ones to make sure you really get it. Last ones for figuring out how to name, okay? So here we go, CO. Okay, my cation name comes first, is gonna be cobalt. And then I have a Roman numeral, okay, because that is in fact a transition metal. And then PO4, look right here, PO4 is phosphate. So it's cobalt something phosphate. And now we figure it out. So there's 3 cobalts and 2 phosphates. Okay, each phosphate has a 3- charge. Okay, so each of these phosphates have a 3- charge. Now I need to figure out what the charge on my cobalt is. All right, so 3 minus 3 minus, that means I have a total of 6 minus from my anions. To balance it out, that means I have to have 6 plus from my cations. Okay, now here's the tricky part when you have something like this, okay? Because these 3 cobalts need to all add up to having a 6 plus charge. Okay, so I can't say each cobalt has 6 plus. I have to make sure that I basically take 6 and divide it by 3. So each cobalt has a 2 plus charge. I have 2 plus 2 plus 2 is 6 plus total. So now my positives and my negatives balance out. Everything's good, okay? And this is going to be cobalt with a 2 plus charge. So this is cobalt 2 phosphate. Almost done. Zn is zinc. Okay, Roman numerals, except just kidding, don't do it, because Roman numerals, except for zinc, right? Except alkali, alkaline, and all these guys. Zinc is always +2, so it's just gonna be zinc and whatever the heck OH is. Please don't be the person that says oxygen hydride, okay? I get it every year. Don't let it be you. You're not gonna do it, okay? The OH is a polyatomic ion, okay? So you get your little page and you memorize and you find, boom, right there, OH is hydroxide. So I have zinc hydroxide. Okay, last one, thank goodness. Okay, NH4, guaranteed. Someone's gonna miss this guy. Please don't let it be you, okay? It's not nitrogen hydride. It's not nitrogen hydrogen oxide, okay? NH4 is a polyatomic, okay? It's a name of a cation. It's the only cation that is a polyatomic that we need to memorize, okay? NH4 is ammonium, all right? So ammonium, which needs no Roman numeral, okay? And then O is going to change its last name to ide. So instead of oxygen, okay, I get a lot of oxygenides. Oxygen changes to oxide, okay? So this is just ammonium oxide. Not too terrible, hopefully. All right, 3 easy steps. You can do this. Good luck.